Okay, so today we're going to start using the properties of logarithms. Okay, so quick recap. That if you have a log of base b, let's say m times n, that's going to equal log base b of m plus log of base b of n. Let me clean that b up a little bit. There we go. Okay, which is your product rule of logarithms. Or if you have log of base b of m divided by n, that means that is log base b of m minus log base b of n. Get a little bit of separation there. Okay, which is the quotient rule of logarithms. Okay, or if you have, say, log base b of m to the power of p. Clean that up just a bit. Then that exponent is just going to come down to the front. So that's going to equal p times the power of log base b of m, which is the power rule of logarithms. Okay, so once again, we're just going to use those three to either expand a log function or contract it to where you have multiple terms, you want to contract it to one log function. One log term. All right. Bring that out a little bit. Oh, I should leave that up for a few seconds. Okay, so for our first example, let's say if you wanted to expand the logarithm log base 3 of 4x to the 4th y to the 8th. We started with a few of the basic ones last class, so now they're going to get a little more complicated. Okay, so here, since you have multiplication, log base 3 of 4 times x to the 4th y to the 8th, automatically, as soon as you see multiplication, and let me put the arrow pointing inside. So multiplication means the product rule. Which means we have the log of m, let's say mn and x. In this case, you have 3 terms. That's going to equal log base b of m plus log base b of n plus log base b of x. Okay. So this just becomes log base 3 of 4 plus log base 3 of x to the 4th plus log base 3 of y to the 8th. Okay. So we took that one log term and expanded it to however many we could. Right. But we're still not done. We have one more property we can use, and that's to get rid of these exponents. Actually, let me bring that down a little lower. So now, using the power rule, remember the power rule is just log base b of m to the power of p is equal to p times log base b of m. Clean that up a little bit. There we go. So for this term, you don't have an exponent, so you're pretty set there. Log base 3 of 4 plus, you can bring that 4 down to the front. So that's 4 times log base 3 of x plus, we can bring that 8 down to the front. 8 times log base 3 of y. All right. So any questions on that one? Okay. So this is your answer, but there is another way you can write this answer. So another way to write the answer. Okay. So here, instead of 4, we know that 4 is equal to 2 squared. So just kind of separating it. Like I said, this would be good enough. This is just if you had a multiple choice problem and they had a different way of looking at it. So that would give you log base 3 of 2 squared plus 4 log base 3 of x plus 8 log base 3 of y. So now that 2 can come down to the front. So it's 2 times log base 3 of 2 plus 4 times log base 3 of x plus 8 times log base 3 of y. It's the exact same answer, just written a different way. All right, so any questions on that one? Okay. Same answer, just written differently. A little bit. All right, for our next example, let's say if we wanted to expand the logarithm log base 4 of square root of x over 16 y to the fourth. So the first thing I do whenever you have a square root or cube root or anything else is you want to get rid of that square root symbol and put it to the power of, in this case, 1/2. So if you remember, that square root of x equals x to the 1/2 power. Okay, so we can rewrite that. That gives us log of base 4. Probably should have wrote that a little lower, but that should be good enough. Of x to the 1/2 power divided by 16y to the fourth. Okay, so we just got rid of our square root bracket. Okay, now we know inside of here we're now dividing. So division means the quotient rule. Uh-oh. Now why did I do that? Means quotient rule. Okay, which is log base b of m divided by n is equal to log base b of m minus log base b of n. Okay, so this one will now become log base 4 of the numerator, which is x to the 1/2 power, minus log base 4 of the denominator, which is 16y to the fourth. Okay, so we got rid of the division, so using the quotient rule for logarithms. But we notice here we still have multiplication in here. Okay, and we know that means the product rule. Okay, so if we go from log base 4 of x to the 1/2 power minus, remember, this entire thing is going to be subtracted. So as soon as you expand it, you're expanding it where both terms will still be subtracted. Okay, so you have log base 4 of 16 plus log base 4 of y to the fourth. And you can use parentheses or brackets. I just use brackets so it wouldn't get confused with all the parentheses we're already writing. Okay. So if you wanted to get rid of those brackets, just distribute your negative. So you have log base 4 of x to the 1/2 power minus log base 4 of 16 minus log base 4 of y to the fourth. Okay. So this looks like it can actually be simplified. Okay, we can always use the power rule for those two, but I'll save that for the last step. Doesn't matter when you do it, but I'll just save that one for last, just so I can simplify that one. Okay, so if we have y, oh, put the y on the other side. Log base 4 of 16 equals y. Okay, so we have our base to the power of y equals x. So that means you have 4 to the power of y equals 16. 16 is just 4 squared. So we have 4 to the power of y equals 4 squared. Okay, so your bases are the same, which means your exponents have to match. So you have y equals 2. And if you wanted to do that on the side, you could. I just do it that way. All right, so if we did go ahead and use the power rule on those two, I'll just make a little, using the power rule for this term and for that term, we end up with, bring that 1/2 down to the front, 1/2 log base 4 of x minus this just became 2. So minus 2 minus, forgot to bring down our 4. Okay, we bring that 4 down to the front, so minus 4 times log base 4 of y. Okay, and that would be our final answer. All right, so any questions on that one? All right, leave that up for a few seconds. Right, for our next example, so if you have, we wanted to expand the logarithm log of base 7 of the 7th root of 2x y to the 4th over 11z to the 6th. Bring that up a little bit. Yeah, make that a little bit neater. There we go. Okay, so the entire thing is under the 7th root symbol. Okay, so the same thing we did with the square root, we're going to do with this one. So remember that the, let's say, 7th root, instead of rewriting all of that, let's say 7th root of x is just x to the 1/7 power. So that means we have the log base 7 of the 7th root of 2x y to the 4th over 11z to the 6th is equal to log base 7 of 2x y to the 4th over 11z to the 6th to the 1/7 power. Okay. So right off the bat, right from the beginning, we can use the power rule to bring that down to the front. Using the power rule, that exponent becomes, forgot to put my 1/7 down in the front, 1/7 times log of 2x y to the 4th over 11z to the 6th. To go from there to there. Okay. So now on this one, we have our division. So division means quotient rule. So now that becomes 1 over 7. Uh-oh, forgot the log of base 7. Times log of base 7 of 2x y to the 4th minus log of base 7 of 11z to the 6th. Okay. So now remember that 1/7 is multiplied by this whole thing. So as soon as we expand that 1/7 is still multiplied by everything there. Okay. So we went from division, we got rid of our division, so we're set there. But each one still has multiplication inside of them. So you have multiplication in there and multiplication in there. Okay, which means the product rule. Okay, so that's equal to, again, you have your 1 over 7. You have log base 7 of 2. Actually, should have moved that over because it's going to expand a little bit more, and I don't want to run out of space. Okay, so that's equal 1 over 7. This becomes log base 7 of 2 plus log base 7 of x plus log base 7 of y to the 4th. Actually need that. Okay, and close the parentheses there. Now minus, now we're going to expand this since it's all multiplication. So you have log base 7 of 11 plus log base 7 of z to the 6th. Okay, and remember that 1/7 is still multiplied to everything in there. Okay, any questions on this so far? All right. Okay, so if we want to go ahead and distribute that to get rid of the parentheses, it's nothing in front of here, so we can just drop those. That's 1 over 7 times log base 7 of 2 plus log base 7 of x plus log base 7 of y to the 4th minus log base 7 of 11 minus log base 7 of z to the 6th. All right. So we can see here that this can't be really simplified, so that stays the same. This can't be simplified. We still have a power rule we can use there, because that exponent can come down to the front. Okay, this one can't be simplified, so that stays the same. This one, same thing, we still have that power rule. Okay, so that gives us 1 over 7 times log base 7 of 2 plus log base 7 of x. We bring that 4 down to the front, so that's plus 4 times log base 7 of y minus log base 7 of 11. That 6 comes down to the front, so that's minus 6 times log base 7 of z. And all of that's multiplied by 1 over 7. If you wanted to, you could distribute the 1/7, but you don't have to. All right, so any questions on that one? All right. Leave that up for a few more seconds. That's a good one. Looks like everyone's done. Might as well reset it.